In this tutorial, I'm going to show how to make an up-down counter in an Allen Bradley Micrologix 1000 controller using RS Logix MicroStarter Lite software. I'm first going to begin by adding an instruction in run here. I'll bring down a contact. This is going to be the contact for my up or increment switch. I'm going to make this word 0, bit 0. I'm going to give it a symbolic name of up switch. I want this switch, this contact, to make my counter go up or to increment. So in the counter, I'm going to get a count up instruction, put it right there. I have to give it a name, C for counter, 5 for the default file that goes along with counters, and I'll say counter number 0. I'll just call this counter. Preset value, I'm going to give it a preset value of 6. So when the counter reaches an accumulator value of 6, the done bit will activate, and I can use that done bit to turn an output on or off. So I finished with my counter there. I'm going to add another instruction, or another rung I should say. I'll bring down another contact. This is going to be for my decrement or down switch. This is going to be another channel, word 0, I'll make it bit number 1, and this is going to be my down switch. This is going to go to a count down instruction. So pulling out my timer and counter tool palette, I'll look for the count down instruction, attach it right there, and I want to give it the same counter name. So this count down instruction will act on the same register, the same file in memory the count up instruction acts on. So that's C5:0. The preset is actually going to be the same as the preset above it. So I make this 6 seconds, and there I'm done. So it turns out later on if I change any one of these, the other one will change correspondingly because they're really both the same counter. So I have a way to make this counter count up, and I have a way to make this counter count down. I need one more thing here to make this practical, and that is to reset the counter. Now to do that, I'm going to add another rung of logic and another bit. I'm going to use another input right here. This is going to be input channel word 0, bit 3. And I want this to be my reset bit. So it's my reset switch. This is not going to go to a count instruction, but I do go to the timer counter palette, and there's a special coil called a reset coil. If I activate this reset coil, it will reset whatever timer or counter I associate with the address. So C5:0 tells me when this reset coil is activated, it will reset counter C5:0. I want the output of this counter, when it hits the preset value, to do something real. So I need one more rung of logic and I'll be done with my program. So insert a rung, I'll go over here to bit, I'll grab a normal contact. This is going to be C5 counter 0 / DN for done. And this is counter done. So when the counter reaches the preset value of 6, it's going to activate that contact, and this in turn is going to energize in a virtual coil to activate a real output. I'll make this output word 0, bit number 3. I'll just call this output. My choice of bit number 3 is completely arbitrary, just as my choice of bit number 0 for the input switch is arbitrary. My PLC trainer has 6 different switches to choose from, and my particular PLC has 4 different outputs, 0 through 3. So I'm done with my program. I should be able to verify here. There are no errors, so I'm going to download to my PLC. So with this program, we should be able to make the counter count up, count down, and then reset at will. And with the program running in online mode, we'll be able to see the status of this counter as we go along. So here we see the red highlighting for virtual power in our program. I'm going to start activating switch 0 right here. And you can see every time I flip the switch, I'm making this counter increment up. And you saw how the done bit activated as soon as my count reached a value of 6. And right here, my output bit 3 is on because it's receiving virtual power from that done contact. I can now start activating this switch, pulsing it. That'll make the counter count down. And notice how the accumulator value in both the counter boxes is going down. When that value passes below the value of 6, the done bit turns off, that virtual contact opens, and I cease sending virtual power to the output coil. Once again, I'll go up. You'll see as soon as I hit the preset value of 6, I energize the done coils, the done bit activates, sending virtual power to the output. I can continue to count up. I can also count down, even below 0. You notice when I get to 0 and continue to count down, I have a negative value in the accumulator. The PLC uses a signed integer word to count the accumulator value for this counter. If I want to reset, I'll show how this works. I'll activate input number 3 on the simulator, and turning that on, input number 3, there we go. I am sending virtual power to the reset coil, and immediately when I do that, the accumulator goes to 0. I can then make a count down or count up, doesn't matter. I'll give some value in it that's non-zero, and I'll hit my reset switch again, and that resets both the counter boxes. It's really one counter, but 2 boxes back to the 0 status. And that's the operation of an up-down counter in an Allen Bradley PLC.